Number 25 is about a swimming pool with some water pouring into it, and we already have some in the deep end. The deep end is about a meter deep of water, the depth of the water. Part A is asking us to find the percent of the pool that's filled. So we have to find the volume of the wedge of water and the volume of the pool. I'm going to start with the pool. The pool is a trapezoidal base prism. So I've got to do the area of the base. So this is the volume of the pool, which is 1/2 base 1 plus base 2 times height. That's the area of the trapezoid times the height of the prism. So it's a prism sort of on its side. The base would be the trapezoid here. That's a base. And the other base is the other trapezoid back here. So base 1 is 1 meter. Base 2 is 3 meters. It's the 1 meter here for base 1. It's this distance. Base 2 is this distance over here. Times the height of the prism, which is the distance from one base to the other. So this is the height, which is 6 meters. And that would represent the volume of the entire pool. So we've got 12 cubic meters. We need also the height of the trapezoid. Sorry, forgot that height of the trapezoid. So the height of the trapezoid is 12 meters, and then times the height of the prism, which is 6 meters. So that is 1/2 times 4 times 12 times 6. $144 cubic meters. That's the volume of the pool. For the water, it's a prism with a triangle base. So the area of the base is 1/2 base times height times the height of the prism. So we've got 1/2 the base of the water. Since it's 1 meter deep, I would call that the base of the triangle, and that's the height of the triangle. So it's 1 by 6. I know that this distance, oops, I know that this distance here is 6 because of the similar triangles. This little triangle is similar to this triangle, and the ratio of the sides, since that's 2 and that's 12, then this ratio here would be 1 to 6. Since I know that's a 1, I then know that the top one is a 6. So that's how I come up with the 6, and then times the height of the prism of the water from front to back, which is 6 again. So that's going to be 18 cubic meters. That's the volume of the water. So if I want to do the percent, it's going to be 18 divided by 144, which is 12.5%. Part B asks for at what rate is the water level rising. So I'll call that dH dt. So if I quickly sketch this thing again, I won't give the three-dimensional look. We know that it goes back that way, but I'm just going to give a two-dimensional look. We want to know, if I call that the height of the water, what is the rate of change for that height of water? So I know the volume of that water is, as I said before, 1/2 B times H times H times capital H. So as I picture this water rising and the volume growing, the one thing that is constant is the height of the prism across. As the water fills up, this height is not changing. It's always going to be whatever it was 6 meters. That's always going to be 6 as the water level rises. So this will always be 6. It's constant. So I don't have to worry about it changing. So now my volume formula is that, because I plug in a 6 for the big H multiplied by the half. So now I still have the base times the height, so the base being this part right here. That is changing, so I have to leave it as a B. But I can't have a dB dt in my related rates, which means that B here has to be substituted for so that I don't have a dB dt. So I'm going to have to write an equation that relates B and H, which I can do. I know that 1H is 6 B's because this was a similar triangle up here. I know that 2 of them gives you, if I have a height of 2, the length here is 12. If I have a height of 1, it's 6. Since it's in that same shape, it's filling up the pool, which is always the same shape, it's always going to hold that 1 to 6 ratio. One height would be one base, 1B, because I wrote it as B up top. 1B equals 6 H's. And I want to get rid of the B, so I make that substitution in my volume formula. So if B is 6H, so then I've got the volume is equal to 18H squared. Now I can find the derivative of that thing. dV dt equals 18 times 2 is 36. H times dH dt. I'm looking for dH dt. I know the rate at which the water is being pumped into the pool. That's 1/4 cubic meters per minute, I believe it was. Yep. Equals 36. They said when the height of the water is 1 meter deep, find dH dt. So I'm going to divide by 36 meters, so I'll end up with meters squared per minute. So then I have dH dt. When I divide by my 36, I get 144. So that's 1/144 cubic meters per minute. And that should actually be meters per minute, not cubic meters per minute. That's because that 10 that's constant from before, or that 6 right here, it's actually 6 meters. So when I plug in the 6, there's already a meters on there. So, yeah. That's the final answer for part B. And that's the rate at which the water level is rising. In the next minute, you could expect it to go up by 1/144th of a meter in the next minute.